Yesterday we had a very brief discussion about how we can get statistics from AFS, and getting statistics from AFS sometimes is not a very good experience. The reason why is because AFS has different command line interface to get stats, even from different layers of the same binary. So today I'm going to be talking about one of the things that I was working on over the past few months, which is a common interface to get stats from AFS servers. So yeah, I don't want to spend that much time talking about the reasons why getting statistics in general is usually a very good idea. We have so many reasons to do that, and if you do that properly, that can help you with questions like what's broken and why. That can also help you to find bottlenecks. Also, you can analyze long-term trends, which can help you with questions like how fast is my VLDB database growing? Am I going to be able to use this database over the next 5 years if the number of VL entries keeps growing like that? You can also measure the performance of a specific version of AFS, which can help you to answer questions like how much faster do I get a response from the VL server if I have, for example, VL and hash enabled, and many more things. But one of the bad things about getting statistics is that usually we have different interfaces to get stats from different components of the system. So sometimes it's not a problem because we only care about one specific component. But sometimes, if we want to understand the reason why this system is behaving like that, we have to have stats from different components so we can somehow correlate them all and find out what's going on. So yeah, here, I don't know if you guys can see that, but yeah, we have 4 components here and 4 different command line interface. So usually it is a very good idea to get stats about the system as a whole instead of only one component of the system. If you do that, you can see your system as a system instead of an unrelated set of components. But do that's not very simple, and the reason why is because each component provides stats in a different way. So yeah, ideally you should be able to get stats from every single component with the same command line interface. So yeah, usually if you want to see your system as a system, you have to have something that's going to be responsible for getting this data from each component and process this data for you. And it's not very convenient. So a possible solution to that problem would be a common namespace that can be used to get stats from every component of the system. So yeah, we have here the same command line interface, and we can use that interface to get stats from every component of the system. And to do that, Solaris 11.4 introduced something called StatsStore. So with StatsStore, you can easily get stats from each component of your system with the same command line interface or with the same API. And one of the great things about StatsStore is that StatsStore can get stats from your application through a shared memory region. So if you have an application and you want to make sure that the admin is going to be able to access stats from your application through StatsStore, you have to create a metadata file, which is nothing more than a JSON file, defining the statistics of your application. So StatsStore uses this metadata file to know the layout of that shared memory that I was talking about. For example, StatsStore needs to know how many 64-bit counters we have on that memory, what's the name of each counter, and so on and so forth. And of course, your application will have to call one of the functions from the StatsStore library to create that shared memory. So yeah, here I have my component, my application, using the StatsStore library. And we have on the other side, StatsStore with the metadata file provided by my application, which is a JSON file. So my application is going to have to call a function from the StatsStore library to allocate memory for the stats. And of course, this library is gonna make sure that this memory is actually a shared memory between my application and StatsStore. And StatsStore, on the other hand, is gonna use that metadata file to get stats from the shared memory. All right, so now let's talk a little bit about StatsStore and OpenAFS. So one of the things that I said before is that we have different command line interface to get stats from different components of the system. And with AFS, we have different command line interface to get stats even from the same process. So here we have 3 different layers of the same process. We have the VL server layer, we have the unique layer, and we have the RX layer. And for each layer, we can possibly have a different command line interface. For example, for the RX layer, we have RX stats. For the unique layer, we have unibug, and so on and so forth. So, yeah, this is not ideal. So, with that being said, one of our customers had this idea that we could use StatsStore and AFS. So you'd have only one interface to get stats from every single layer in AFS. And not only AFS, but the same interface to get stats from the whole system. So to make it possible, we had to do a lot of refactoring on the AFS code. So we had to move some stats. We had to move some stats to the same script, and we had to use the StatsStore library to create the shared memory for each script. So I have an illustration here to show you guys how it looks like. We have 3 different layers, and each layer is going to have shared memory. And we write the stats from each layer from that shared memory. The StatsStore gets the stats from that shared memory. So here you have a screenshot of this web interface that was getting stats from AFS through StatsStore. So I have 4 layers here. The first one is the VL server layer. So we have the number of times that the function find by ID was called. On the other side, we have the number of times that find by ID was called. And on the second layer here, I have something that Mark was talking about 2 days ago, I think, which is the VL memhash layer. So we have here the number of times that the name of a specific column was found in the name table. And on the other side, we have the number of times that the ID of a specific column was found in the table. And on the third layer, we have the unique layer, the number of times that the flush was called, and the number of times that the read was called. And finally, at the last layer, we have the RX layer. So the number of data packets read, the number of data packets sent. So of course, we have way more stats than that. But yeah, I could not plot everything on the same screen, so I just have this example here. But we have a big problem with StatsStore. So what's the problem? Well, it is Solaris specific, and we do not have that many people using Solaris anymore. So we don't want to have to refactor a lot of things on the AFS only for one platform. We have to somehow provide a similar facility to other systems. And to do that, we use collectd. So collectd is an open source team that gets stats from each component of your system. That's how collectd looks like. So if you want to provide stats from your application to collectd, you basically have to create a plugin for your application that's going to let collectd knows how to get stats from your application. So yeah, we have many benefits of using Collectee. It's open source, extensible, it's free, lightweight, and we have a lot of plugins already developed for Collectee. And the most important thing, it is widely supported. Linux, Mac, FreeBSD, NetBSD, and so on and so forth. So it's a very good option for us. So basically, I had to make a plugin for OpenAFS, and this plugin works like StatsStore. So AFS creates a shared memory for the stats, and Collectee gets the stats from that shared memory. And yes, Collectee has a configuration file, and we use this file to let the OpenAFS plugin knows how that shared memory looks like. So yeah, here we have the OpenAFS server that's going to be responsible to create the shared memory. And on the other side, we have the Collectee with a configuration file and the OpenAFS plugin made by me. And yes, on OpenAFS, we have both implementations. We have the implementation for StatsStore, and we have the implementation for Collectee. And we use the same interface to initialize the stats module. So if we have StatsStore, we use StatsStore. If we have Collectee, we use Collectee. And the plugin for Collectee can be found on my GitHub, on that link. But I did not publish the patches for AFS yet, because these patches were developed on top of one specific branch from a customer, which is based on 1.6, and I had to do a lot of refactoring. But anyways, the patch for master branch comes soon. But if you guys want to take a look on the plugin for Collectee, you can find it on that link. So here's how it works. So as I said before, we have the same interface to initialize this module, AFS. And if we have StatsStore, we use StatsStore. If we have Collectee, we use Collectee. And yes, here we have a screenshot of Grafana getting stats from AFS through Collectee. But yeah, we have way more stats than that, but just an example here. And that's pretty much it. So very brief. Oh, anybody have any question?
So you got like RX layer, cubic layer, whatever PL. So would you could you potentially get like other statistics, for volume server, have certain number of transactions that are on?
Yes.
Like that.
That's
all that available?
Yeah, some statistics are not available, so Robert asked me to create some new stats for the volume server and for other things. And for the file server, he'd like, for example, he'd like to know how many volumes are attached, how many volumes are not attached. So I had to create these new stats for some specific process.
So the Collectee plugin, that's a separate piece that it fetches data from the OpenAFS team. Like they set up the shared memory, so we have a way of accessing the shared memory and pull it in. So it's not necessarily a Collectee specific. Like Collectee is great, but you could, if you have another system, you can write something to pull those stats from.
Yeah, you just need to know how the shared memory looks like.
Yeah. So just mentioning, it doesn't have to be Collectee specific. I think the main benefit is that there's a common way of getting the stats out for whatever system you want to use.
Yeah.
Yeah. And I think something else that's really helpful here is it's not over the network, so there's no, so if anything is broken with the network processing or anything, you can still get stats. There's no request to make. It's just, it's an area of memory you just get.
Yeah, it's good and bad because we have to run the plugin on the same machine.
Yeah,
I think that's good.
I mean, that's good. Yeah, I do think that's how most things work. So traditionally, we do have the network access, and that's convenient, but it's a little unusual. And I think these stat, they should be more easily extensible. Some of the existing OpenAFS stat structures, like some of them are, like XStats is easy to add new ones to the end, but some other ones are based on like specific, we have a fixed struct. You can only add so many things to that struct. But at StatsStore, at least, I think like it's mostly string based. Like you have these strings with delimiters. And I'm assuming the new way, like we're making it pretty, you're trying to make it pretty extensible, so it's easy to add new stats. You can just change, yeah. So we don't need to keep all the old ones. Like you can get rid of them if they don't make any sense anymore.
So I guess with this sort of thing, using the shared memory, you just need to make sure that the producer and the consumer of the shared memory agree on what's there. Talk about, of course, the creation file that you replace, JSON file or not. And then obviously we try very hard to make sure that the JSON file is updated when the OpenAFS version is updated. I just sort of wanted to think through, if somehow they get out of whack, how bad is that going to be? It's just going to be redrafts.
It's like if you add new stats to the end of this struct, that's not going to be a problem. But yeah, if you add new stats in the middle of this struct,
But so in StatsStore at least, all the stats are defined as like, here's a field and it's like a 4-byte integer.
yes,
Right. So they're all like that. So there's not like a different interpretation of different structs. I'm assuming like the collectee shared memory thing is a similar kind of style.
yes.
Yeah. So I think the main problem with that is just misidentifying stats. It doesn't really. We don't usually have different interpretation of
value. Use a different offset.
If you add a new stat, it's a new stat. So 32 bits integer, for example, that can be called. Because StatsStore assumes that every single column has 64 bits.
Or 60, yes, everything is 64 bits.
64 bits, yeah.
So right now it's kind of like XStats like that. Like the XStat framework is just everything is one number. So like if you have a stat and a number, So it's not like you don't typically have like a stat and then a struct or something like that. They're usually individual items.
You just be looking at your graph and saying, oh, geez, the number of volumes getting reclaimed is growing alarmingly. It's just the number of connections that's right.
Well, and I feel like it's possible to maybe pull the data, even if you don't have the definition file, you can still pull the data out, and you could have something like post-process it later if you wanted to.